We'll solve one question where a polynomial is given to you. A polynomial is given to you, and the polynomial is 3x cube plus 10x square minus 9x minus 4. This is the polynomial given to you, right? And this polynomial is having one of its zeros as 1. So we need to find all the zeros of this polynomial, right? So let this polynomial as function of x, right? So I'm writing it over here, f of x. This is a function of x because this polynomial is in the variable of x, right? So the zeros, so what is the degree of this polynomial? You can see the maximum power 3. So there will be 3 values, 3 zeros for this polynomial, right? So just how many zeros? 3. The zeros of this polynomial. Zeros are also known as roots. Roots means your values all are equal, right? So how many zeros you will have here for this polynomial? 3. 3. And out of these 3 zeros, if one of the zero is 1, right, then you need to calculate the second and third zeros. This need to be calculated, right? You need to find it out. Question mark. Okay, I am putting it over here like a question mark, right? Now to solve this polynomial, you know that since one of the zero is 1, so we are getting the value of x as equal to 1. Or since x equal to 1, that means x minus 1, that when 1 will be going to the LHS, x minus 1 will be the factor of, is a factor of what? Fx, this function, this polynomial. So x minus 1 is the factor of fx, right? Now, since this is a factor of fx, let us solve and find these 2 zeros, right? For this, what we will do? Take this constant number 4, okay? So I am writing the fx, that is our polynomial, as given into the question 3x cube plus 10x square minus 9x minus 4. So here the constant is 4, right? Take this constant because we will be applying the remainder theorem over here to solve this, right? What we will apply? Remainder theorem. What? Remainder theorem, right? Just to recall. Now take the factors of 4. So 4 can be written as, the factors of 4 are 1, 2 and 4, right? And take the plus and minus sign both, because when you multiply minus with minus, it will be coming as plus. So the factors of 4 are plus minus 1, plus minus 2, plus minus 4. You can verify it. Since these are the factors, then one of the factor is 1, which is given to you in the question, that x equal to 1, that is x minus 1 is the factor of fx. So you can see one is given to you. Now let us, by using the remainder theorem, let us factorize it, right? Since the value of f of x when you put the value of f of x for x equal to fx will be 0 for x equal to 1 being a factor, right? So what we will do, we will just factorize this and will spare x minus 1. Understood, students? Now 3x cube plus 10x square minus 9x minus 4. So we need to spare x minus 1. Since this is the factor, we need to spare x minus 1. So how we will do it? Let us see. 3x cube is the first term. When you want to spare x minus 1, what will be the second term? This will be minus 3x square. Just I am writing it my own thought. Okay. And you can also think and add it over here. Right? Now, when 3x square will be taken common from these two terms, you are left with what? X minus 1. So x minus 1 is there. Now, since we have inserted minus 3x square, we have only 10x square. Since this is extra inserted, that need to be compensated. So what we will do? We will add 3x square, right? Then plus 10x square. This will give you 13x square minus 9x minus 4, right? So now this equation will be looking like this function of x 3x cube will be looking like 3x cube minus 3x square, because from these both two you can take out this factor x minus 1, and from this you are getting the another one x square as 13x square. If this is 13x square, you need to insert another number such that from the both you can take something common and we are left with x minus 1, right? So here you will be inserting minus 13x. Why, students? Because when you take 13x common, you are left with x minus 1. This is the remainder theorem. Now, since we have inserted minus 13x by own, so that's why initial in the previous line you can see only minus 9x was there. So what you will do, you have taken minus 4x extra, so just write compensate that. When you add plus 4x, that minus 4x will be settled down and the last term will be minus 4. Here you can see it is set now. From 4x minus 4, when you take 4 as common, you are left with x minus 1. Now, this will be from these two initial terms, first two terms, when you take 3x square common, we are left with x minus 1, right? From these two terms, when you are taking 13x as common, you are left with x minus 1, isn't it? And from these last two terms, if you are taking 4 as common, we are left with x minus 1, right? So from all these three terms, now put x minus 1 common. This x minus 1, just bring it out, this one, this x minus 1. This x minus 1 is common in all these three. So bring this x minus 1 as common, right? And inside the bracket we are left with 3x square plus 13x plus 4, right? Now for 3x square plus 13x plus 4, for 3x, for this one, using the same as we did earlier, take the constant term and for this take the factors. So factors of 4 are plus minus 1, plus minus 2 and plus minus 4. So when you put the value, of, let us say this is f dot x, right? This is f dot x. So for f dot x, we can see the factors. When you put the value of x as their factors, again 4 is there, right? So we can see the factors. What are the factors? The factors are plus minus 1, plus minus 2 and plus minus 4, right? Now what we will do? We will do simply factorize it. How? Let us see. From this, actually this page is filled up, so we are using the second page. Just a minute. Yeah, right. Now from this step we have f of x as x minus 1, this one, into f dot x, that is 3x square plus 13x plus 4. Now the factors of 4 we have seen plus minus 1, plus minus 2 and plus minus 4. So when you put the value of 1, right, it is 0 because it is already a factor. But when you put the value of minus 1 from here, the f of minus 1 will be not equal to 0, right? You can see 3 into minus 1 whole square plus 13 into minus 1 plus 4. So this will give you 3 minus 13 plus 4. So this is not equal to 0 because 3 plus 4 7, 7 minus 13 not equal to 0. So for this factor of 1 minus 1, f of minus 1 not equal to 0. Similarly, for f of 2, this is not equal to 0. You can check. I will not take that much of time, right? And for f of minus 2 also, this is not equal to 0. You can check it. You want me to check? Let us see. For f of 2, this will be 2 minus 1. So 2 minus 1 will be 1 multiplied by 3 into 2 square. 3 into 2 square plus 13 into 2 plus 4. So whatever the value you are having, that is plus, that is in plus, and that is not equal to 0. So that's why we written f of plus 2 is not equal to 0. But when you put f of minus 2, that is also not equal to 0. And when you put f of 4, that is also not equal to 0. But when you put f of minus 4, x equal to minus 4, then the function f of x will look like this. F dot x, this one. This is f dot x. F dot x is 3 times minus 4 whole square plus 13 times minus 4 plus 4, right? And this will give you 4 4 16 into 3 48, 13 4 minus 52 and plus 4. You can see 48 plus 4 52, 52 minus 52. So that is equal to 0. So we can say that the another factor which is coming in front of us is what? Minus 4. So minus 4 is a factor factor of f dot x. And what is f dot x? 3x square plus 13x plus 4. So we can write f of x as x minus 1 times f dot of x, which is equal to x minus 1 times f dot of x. What is f dot of x? That is 3x square plus 13x plus 4, right? This one. Now what we will do? We have considered minus 4 as the factor. That means minus 4 is the factor. That means we have to take common x plus 4, because x plus 4 will give you the value x equal to minus 4, right? Now from here, just using the remainder theorem, we will solving it. 3x square, write the first term as it is from f dot x, 3x square. Now you have to bring out 4. So what we will do, we will add 12x. From 12x, from these two terms, when you bring 3x common, we are left with x plus 4 from these initial two, right? Now this 12x is inserted, so that need to be subtracted. So minus 12x will be there. So minus 12x plus 13x plus 4, right? This we are having now. This will give you x minus 1, and from 3x square plus 12x, you can see 3x can be taken as common, and we are left with x plus 4, which is our another factor which we have decided, which we have calculated. For this is f dot x is 0. So that's why x plus 4 is taken out, and from minus 12x plus 13x we can write it as plus x plus 4. So here also is automatically settled, right? So from this x minus 1, and from this x plus 4 and x plus 4, and if you multiply it by 1, so you can see x plus 4 is taken out, and we are left with 3x plus 1. So this will give you for fx the three factors, the three zeros. So the three zeros from here we can see, when this is equated to 0, this will be x equal to 1. When x plus 4 is equated to 0, this will give you x equal to minus 4. And when 3x plus 1 is equated to 0, this will give you the x value of x as minus 1 by 3. So 1, minus 4 and minus 1 by 3 are the factors of the, or the zeros of the polynomial. Which polynomial? I'm just, yeah, 3x cube plus 10x square minus 9x minus 4. And this is our answer. So using the remainder theorem, we have solved it. I will show you. Actually, I have used 2 pages to solve. Okay. Here the main factor polynomial is given to you. Just we have, it's a degree of 3. So we have the value of this polynomial. When you solve it, you get 3 values, right? One of this is given as 1. This one, we need to find the second and third, right? To find the second and third, we identified what are the numbers when you put the value for that x, it will become 0. So those will be the factors, right? Here we can see the number, the constant term, we need to take the factors of that, right? So the constant term here is, in this polynomial, is 4. So we derived the factors of 4, that is plus minus 1, plus minus 2 and plus minus 4. So for these 6 numbers, that is plus 1, minus 1, plus 2, minus 2, and plus 4, minus 4, okay, when you put the value, since x equal to 1, it's a factor which is already given to you, right? So this will be one of the factor. So if x equal to 1, we can say x minus 1 equal to 0. So from the given polynomial fx, right, that is 3x cube plus 10x square minus 9x minus 4, we will bring out x minus 1. How? By using the remainder theorem. Using the remainder theorem, we inserted minus 3x square, because from these two terms you can see when 3x square will be taken out, we are left with x minus 1. And since minus 3x square we have inserted, we have added 3x square. And earlier it was 10x square, so now it become 13x square. And now 13x square, now we will insert minus 13x over here. Why? Because from these two terms, when 13x will be taken out, we are left with x minus 1, right? Since it was minus 13x which was inserted, but earlier it was minus 9x only. So that's why plus 4x is added to compensate that. And finally we can see it's automatically set from 4x minus 4. When 4 is taken common, it's x minus 1. So we are we have factorized our given polynomial fx as x minus 1 times 3x square plus 13x plus 4. Now again using the remainder theorem, just find the factors of the constant term. So this is plus minus 1, plus minus 2, and plus minus 4. Since x equal to 1, that is x minus 1 is already factorized and already considered, we will consider the other values minus 1, plus minus 2, and plus minus 4, right? From here you can see when you put the value of x as minus 1, the fx is not equal to 0, right? And when you put the value of f of 2 for x equal to 2, this is not going to be 0, not equal to 0. You can just put up the value. I've shown it over here. When f equal to minus 2, the above polynomial is not equal to 0. But when you put the value of, even for f of 4, this is not equal to 0. But when you put the value of x equal to minus 4, this will become f dot x. That means the second part of this polynomial, this one, right? This is written over here as f dot x, right? This will be 0. You can see 3 times minus 4 square plus 13 times minus 4 plus 4. We have put the value of x as minus 4 in this equation, f dot x. So we can say that f of minus 4 is the factor of the second part of the polynomial f dot x. Since minus 4 is the factor of f dot x, we can say that x plus 4 equal to 0, because this will give you x equal to minus 4. That means now we have to bring x plus 4 out from the f dot x. This is f dot x, right? How we will be doing it? How? From this, in the same fashion, since x plus 4 need to be taken out using the remainder, what we will do, 3x x minus 1, just write it as it is, right? Since we are speaking about f dot x, this is f dot x. Since we are speaking about f dot x, so this will be 3x square. Write the first term as it is, 3x square plus what need to be added? We have written 12x by our wisdom. Why? Let us see. Because from 3x square and 12x, when you bring 3x out, we are left with x plus 4. X plus 4. So x plus 4 need to be taken out because that is our factor, right? So since 12x is inserted, but that was not present earlier, so that's why minus 12x is written over here, so that 12x and 12x will be cancelled out, right? But earlier it was 13x, so write 13x plus 4 as it is. Now we are left with x minus 1 times, from these two terms we brought 3x out, right? Then we are left with x plus 4, and from minus 12x plus 13x plus 4, Here you can see we are left with x plus 4. So finally, when x plus 4 is taken out from the f dot x, we are our polynomial f of x will become x minus 1, x plus 4, 3x plus 1. So this will give you the zeros value, that means the roots or the values of that particular given polynomial as x equal to 1, minus 4 and minus 1 by 3. So these are the three zeros of the polynomial 3x cube plus 10x square minus 9x minus 4. And this way we have solved the question. Students, if you find it useful, you can like and subscribe. Thank you so much for watching. Happy learning. Bye bye. Take care. Thank you. And you can, any query you can put up in the comment box, even you can message me. Okay, thank you. Even I put the shorts of this, I will attach this video to that shorts so that you can see the explanation in detail. Thank you. Bye. Bye bye.